It's asking which statement about hydrogen bonding is true. Okay. So I want true statements. So A here is hydrogen. I'm gonna say H bonding instead of hydrogen. H bonding is the intermolecular attractive force between two hydrogen atoms in solution. Is intermolecular force between two H atoms in solution. And right off the bat, we know that this is here is false, right? H bonding is not between two hydrogen atoms. If we recall hydrogen bonding here, H bonding only exists with three molecules, with N, O, and F here. So this here is not true. So A here is not true. B says that the hydrogen bonding capabilities of water molecules cause C3H2, CH2, CH2, CH3 to be more soluble in water than CH3OH here. So that is also not true. And I'm not going to write that down because CH3OH here is a polar molecule because there is and it also contains hydrogen bonding, right? I can say here is H bond between the H and the O here. Whereas if I had, this is CH3, CH2, CH2, CH3, this here has no hydrogen bonding that exists here. No H bonding. And this guy here is also nonpolar. And because we know that water is water, let me just in blue because water, I know is a polar solvent. And if I know that like dissolves like, so methanol would dissolve in solution, and so this is soluble. And this guy here, butane, is non-soluble, right? Because it's nonpolar. Non-soluble. So therefore B is false because CH3 is not more soluble in water than C3AOH. So this here is not true. So I can X this B, not correct. And A here is also not correct here. I'm looking for the true statements here. C is asking hydrogen bonding of solvent molecules with a solute will not affect the solubility of the solute. Let me say that again. So H bonding of solvent molecules with a solute will not affect the solubility of the solute. Well, it does, right? Because I told you, like in this previous question, methanol here is the solute, and the solvent is water, right? So water, H bonding is in water, obviously, with a solute. This hydrogen, the hydrogens on water can also hydrogen bond with the methanol here. So it does affect the solubility of the solute because this makes it a soluble molecule. So this here, C would have to be, this here is, it would affect the solubility. So H bonding of solvent with solute affects solubility. And the reason why, so again, this statement is also false. And the reason why is that if I were to draw out the molecules here, of H here, this here is hydrogen bonding, but also have CH3OH, right? So let me write this here. So I have C3OH here. And this, so again, these guys here, so I can hydrogen bond. So this here is a hydrogen bond. Let me just in blue. Hydrogen bond here. Again, these guys here, this is a partial negative charge. This here is a partial positive here. So again, these guys here are going to be attracted, right? This hydrogen here is going to be attracted to these water molecules, and these hydrogens are going to be attracted to this oxygen molecule, right? So this is the hydrogen bonding that exists between the solvent and the solute. So C has to be a false statement here. I have D here is asking us hydrogen bonding interactions between the molecules are stronger than covalent bonds. Covalent bonds hydrogen bonding interactions between molecules are stronger than the covalent bonds within the molecule. So this statement here is, so they said here is not true. But I'm thinking of the wording here. Hydrogen bonding interactions between molecules are stronger than the covalent bonds within the molecule. So so this is a trick question. So hydrogen bonding between molecules are stronger than the covalent bonds within the molecule. So again, this is not true as well. So this solution is correct, but the trick here is that hydrogen bonding, we know that hydrogen bonding is actually stronger than covalent bonds, but this has to be only within the molecule. When we talk about between the molecules, then it gets a little bit trickier. So that's kind of a trick question in the sense that hydrogen bonding is actually stronger than covalent bonds only if they're both within the molecule. But in this case, it's asking is hydrogen bonding between molecules here. This is the trick here, between molecules. So I'm going to say here, this here is also false because H bonding within molecules are stronger. Than covalent bonds. Okay, which makes the E has to be true, right? Because I had 4 false statements. It says here, hydrogen bonding arises from the dipole moment created by the unequal sharing of electrons within certain covalent bonds within a molecule. So this is like, so this is true, but it's actually like it's not as specific as I want it to be, because what we're talking about here is hydrogen bonding arises from the dipole moment created by the unequal sharing of electrons within certain covalent bonds within a molecule. This can actually be with anything, right? Then if I had a C bond F here, this here also has a dipole moment created by unequal sharing of electrons. But again, I don't have hydrogen here, so this can't be hydrogen bonding, right? This here is partial positive. This guy here is partial negative. So this question is actually not the greatest question in my opinion, because this here, if they're defining hydrogen bonding that arises from the dipole moment created by unequal sharing, then this here would be considered a hydrogen bond, right? By this definition. However, it's not, because there's no hydrogen here. Hydrogen bonding only exists with nitrogen, oxygen, and fluorine. So this is actually it's not a good question at all, actually. This here is not a good question. So I'm going to say that this here, E here is true, but in a specific condition. And I understand the concept that's happening here because they're using hydrogen and oxygen here, but I can use a counter example of this carbon bonding to fluorine, and this by definition would still be hydrogen bonding technically, which is false. So I'm going to say solution is correct, but question is terribly phrased. So I'm going to copy and paste this and say the definition, or I'll say this definition of hydrogen bonding is not true. Not true. And I give a counter example here. If I have C bond F here, in the single bond between carbon and fluorine, there is a dipole moment that creates by whatever. I'm just copy and paste this. Dipole moment created by the unequal sharing. Therefore, by definition, this would be considered a hydrogen bond. However, we know that that is not possible. It's not possible because hydrogen bonding only exists with a hydrogen exists with the inclusion of a hydrogen with either nitrogen, oxygen, or fluorine. So question is poorly phrased, but correct solution. So again, this is not the greatest solution here at all. D here is a bit tricky in terms of the wording. I think a lot of people would have fallen for this trap in writing D is true. But I think if they even just switched this word into within molecules here, this would have actually been a true statement, because hydrogen bonding is stronger than covalent bonding. Hydrogen bonding is stronger than dipole moments, but dipole moments in intermolecular forces. But again, it's not stronger than covalent bonds. So it's very, very, very tricky here, this question. So the solution is correct, but I didn't really like this. The phrasing of the question is just not very, very good.